Hello everyone, congratulations on making it to topic 11. This is the video for topic 11, lesson 1, and we're going to be looking at proportional and non-proportional linear relationships on a graph. I'm going to continue using lines and graphing, plotting points and things of that nature, but we're going to look at whether things are proportional or non-proportional. So let's talk about what it means to be proportional. A proportional relationship is going to have a constant rate of change and a constant output to input ratios. We'll get into that a little bit more later in the topic. Non-proportional relationships, it might have a constant rate of change, but it is not going to have constant output to input ratios. Again, we'll get more in depth with that as we go into the topic. So when we're looking at a graph and we have a line on a graph, there are some visual clues that we can tell that it is a proportional relationship versus a non-proportional relationship. If you have a proportional relationship, the line that you will see on the graph is going to be a straight. So a proportional relationship will be a straight line. And that line will pass through the origin of the graph. Again, topic 9, we talked about graphing and the origin. We should all understand that's located at 0, 0 on a graph. So that line will be a straight line and it will go directly through the origin. A non-proportional relationship might be a straight line, but it is not going to pass through the origin. So again, big difference there when we talk about proportional and non-proportional. If it is a curved line, instantly non-proportional. If it is a straight line, then we need to double check and say, does that line pass through the origin? If it does, it's going to be proportional. If it does not, it is going to be non-proportional. Let's go ahead and look at some examples and decide whether or not they are proportional or non-proportional relationships. So I'm going to have to do some graphing. So I'm going to graph the 2 points. I'm going to graph the point 0, 3. 0, 3, I would start at the origin. I would not move left or right. I would just go up to 3 and plot my point. And for the point 4, 5, I would start at the origin, go to the right 4, and then up 5. So I have my 2 points. And use your straight edge or your ruler to connect those lines, those dots to make your line. And then we can see whether or not we have a proportional or a non-proportional relationship. Remember, for it to be proportional, 2 things must happen. You must have a straight line, and it must pass through the origin. So does that blue line, is it a straight line? And the answer to that question is yes. But does that blue line pass through the origin? And the answer to that question is no. So this is a non-proportional relationship. We can abbreviate. We're just going to abbreviate it NP from here on out. All right, not NP, non-proportional. Again, I have a straight line, but that line does not pass through the origin. Instantly becomes non-proportional. Let's look at the second example here. I'm going to graph these 2 points. 2, 2. I would start at the origin, go right 2, up 2, plot my point. And then -6, -6. I would start at the origin, go left -6, and then down to -6. I have my 2 points. Can use my straight edge to connect those dots as best as possible to form our line. And again, asking ourselves a couple of questions here to decide if it's proportional or non-proportional. Do we have a straight line? The answer to that question is yes. And does that line pass through the origin? And the answer to that question is yes. So this is a proportional relationship. Just refer to it as P from now on, all right? Again, straight line passing through the origin instantly makes it proportional. Let's go ahead and look at the last two examples here at the bottom of the page. Again, I'm going to graph the 2 points before I make any decision about it being proportional or non-proportional. So to graph -6, -5, I'm going to start at the origin. I'm going to go left to -6 and down to -5. Plot my point. To graph 4, 3, I would start at the origin, go right to 4, and then up to 3, and plot my point. Again, I'm going to use my straight edge to go ahead and connect these points. I'm trying to get right through the corners of those squares on your graph. And then we have a couple questions. Do I have a straight line? The answer to that question is yes. Does that line pass through the origin? And you can see really, really closely if you look that that line does not pass through the origin. It is very close to the origin, but it does not pass through it, which makes it a non-proportional relationship. NP. For the last one, I'm not going to do any graphing of the points because it would just be a little bit too complicated, but I do want to show you an example. If you have any curved line, it is instantly going to be non-proportional. So that is a curved line. I understand that it passes through the origin, but because the line is not straight or it has curves, that instantly is going to make your situation non-proportional. So make sure you understand 2 things have to happen in order for it to be proportional: straight and pass through the origin. You can go ahead and slide down and try these 4 practice problems on your own. You can check back in a few seconds and I'll have the results up there for you to look at. All right, here are the results for the practice problems that I've asked you to do on your own. Double check a couple things. Make sure your points are plotted in the correct spot. Make sure your lines look like mine, and then obviously make sure you have identified them as proportional or non-proportional correctly. Make sure if you have any questions about anything or something is not making sense to you that you aren't afraid to ask questions. You come talk to one of us so we can clarify before we move on.